Okay. Rule number 3. Okay, rule number 3 says that moving a takeoff point after the block. Moving a takeoff point, heading is moving a takeoff point after the block. So we need to move a takeoff point after the block. How we can do it in, so we already have talked about the takeoff point. What is a takeoff point? It's a point from which signals from a block goes concurrently together to the more than one block or summing point. So from this point, number of signals will go to the summing point or a block. So that we already know. So let's see. That's also called a branch point. I have told you. Now, what does the rule clearly says? It says that shifting of a takeoff point from a position before a block to a position after the block okay is shown in. Let's draw the figure for it. So what is the point? Point is that rule is we need to shift takeoff point from a position before a block. That means any block is there, transfer function is there, and after the block we need to move it. So let's see. So this is the way the okay, and this is your transfer function here, and this is as usual rs, that is your input. Let's say this is a position a for the takeoff point, and this is your transfer function g of s. This is output. This here you can say this is again input. Now if this is the scenario and we need to move a takeoff point, a is a takeoff point before a position, from a position before a block, that's it is presently at position before the block, and we need to move it after the block. That means somewhere here we need to move it. That means somewhere here. So let's say this is the point where, sorry, let's say this is the point where we need to move it. So this is the rule: moving a takeoff point after takeoff point from a position before a block to a position after. Let's see. The main important things here are the integrity of the circuit at any point of time will not change. Now let's see how we will do it. So first what we have to do, this is as usual input. Sorry, I will change the pen color. This is as usual input. Okay. And if you move further from here, we'll get the same thing. That means Just a second, sorry. Okay. Now here you can see this is input, this is transfer function, and this is the output. This scenario is not going to change. But our takeoff point, we have to move here. This point has to be moved here. So this is as usual RS. Okay. This is as usual CS. No change in these cases. And transfer function will remain as it is. G of S. Sorry. Transfer function is G of S. So this line we have not changed because we are not going to do anything with this. We have to move this. Now while moving this, you can see clearly here. I'll mark this again in the red. Okay. See here. Here. This point we have to move this to here. That's why I'm showing the arrows. Okay. Now I'll be drawing it. Now, if I have to draw it, what is the current scenario? This is transfer function. This is input. Output by, we need to get the output. What will be the value of output? Output by input. Here I will write inside for your information. You know itself. We know that if output by input, I write in generalized form, output by input is transfer function. But here we know input, we know transfer function, we should know output. Output will be transfer function into input. So output will be transfer function is G of S, input is R of S. So that is R of S into G of S. So here we can clearly write this value as R of S into G of S. So up to here the value is R of S, G of S. But now this point has been shifted here. Now while shifting this point, we'll shift it like this. Okay. While shifting this point, sorry. Okay. See, while shifting this point, you can see some manipulations have, this is RFS, GFS here also. Here we'll see we have RFS, GFS coming to this. Now here output is CFS, that's not going to change. Here input to this side, this is again RFS, GFS. So we can write it here. This is RFS, GFS. Now this transfer function we know, we don't know, but what we know in order to manipulate this value, in order to get this value, we know this value, we can't change this value. This value is R of S. See here, this is R of S. I will again repeat, first branch will not change. Then while we are moving from the takeoff point, the input from this takeoff point is R of S, G of S. It's very clear from here. Current scenario, the input is up here is R of S, G of S here. Out of that R of S, G of S, output here is C of S, but here output is again R of S. Here now the output is R of S. Now input is R of S, G of S. Output is R of S. Input is R of S, G of S. So transfer function in this case will be 1 by G of S. How we know that? This is output by input. That means this is R of S divided by R of S, G of S. Output by input is transfer function. So the value of transfer function R of S and R of S gets cancelled. It's 1 by G of S. So this is the way when you have to move a takeoff point from a position. When you have to move a takeoff point from a position before a block to a position after the block, then this manipulation has to be done. That means while we transfer it, you have to keep transfer function as transfer function value will change from g of s to 1 by g of s in that branch. Transfer function value will change from 1 by g of s to 1 by g of s in that branch. I hope this is clear. Tanzib,
Clear, sir, clear.
anybody has a doubt in this case, then I will move ahead. Can raise this query. Okay, let's move to the next rule. Rule number 5. Sorry, rule number 4. Let me write in the red these rules. Rule number 4. Exactly same thing we are doing now, but just a bit change is there before a block. Now we'll move to the ahead of block. So next is moving a takeoff point ahead of the block. So we need to move takeoff point ahead of the block. So what is the complete rule saying? Shifting of takeoff point from a position after a block to a position before the block, as shown in figure. So let us see how we can do this. So now what is the scenario here? Scenario is this is okay. So this is your transfer function. So change it. Okay. Now what we are going to do here, this is your input RFS. This is a transfer function. Now takeoff point is here at the position B now. Now what we are going to do, this is output and this is also an output. Same thing because this is same. Here we can't change anything. So here we can see what we need to do. We need to move this takeoff point from a position after a block to a position before the block. So here we may need to move this takeoff point. That point A, let's suppose that is a point A. From point B to point A, we need to move it. So how we can do this? Let's see. Now here, I'll be drawing again. Oh, sorry. Okay. Now again, this branch I am not going to change. That means RFS, GFS, and CFS will remain intact. Now, because this point has to be moved here. So let me draw this first. So this is your RFS. This is not going to change. So this is as usual. This because we need to move only takeoff point. Some manipulations have to be done at the takeoff point. See, we need to move at this point. What should we exactly do? Let's see. So this is output by input is transfer function. But the value of RS can be written as also RS will be equal to, see, we know this output, sorry, we know this output by input is what? It's a transfer function, G of S. We need to get the value of this RFS. RFS will be output C of S divided by G of S. So I can write RFS of C of S divided by G of S. So I will write this value here. Okay, let me draw this first. So here input going will be RFS value can be also written as C of S divided by G of S. So input going to something is, let's say that's a block, that is C of S by G of S. Now output again we know here, see, we are moving this to this point, but output is not going to change. Output is same. Integrity of the circuit is not going to change. So output will remain as C of S. These are known things to us. Output again is C of S. Output is known to us, that is C of S. So this value is output, this is input. Output divided by input is transfer function. So value of the transfer function will be here. So the value of transfer function will be, value of transfer function is, transfer function can be calculated here. That is output divided by input, that is C of S divided by G of S. That will go up. So C of S gets cancelled. So which means that whenever you have to replace the takeoff point from a position after a block to a position before the block, then you have to multiply that there by a transfer function which will be equal to G of S only. So this is the rule number 4th. Let's move to the rule number 5. So rule number 5, what it says, rule number 5 is moving a summing point before a, sorry, moving a summing point beyond a block, that means after the block. Moving a summing point beyond the block, beyond a block. Moving a summing point. So this is the point. Now let's see what we can do. Just to elaborate this point, shifting of a summing point. What is this rule saying? Shifting of a summing point from a position before a block to a position after the block, as shown in figure. Let us see. So let us draw the circuitry and then we'll see how we can move a summing point from a position before a block to a position after the block. Let's have a look at this. What we'll be doing here, let's say scenarios like this, let's say circuitry is like this. We have a summing point. We'll draw a summing point here. Okay, this is a summing point. Okay, signal going to the summing point. This is here plus. Okay, this is here plus and minus. Let's say this is plus and minus. Now again we have output from the summing point, and then we have a transfer function. Okay, and then we have output. Okay, and this signal is, sorry, so here this is the circuitry we have. RFS is this one. So there here we have X of S. So RFS, this is plus minus X of S. Here we are getting RFS, sorry, plus minus X of S. That's what we are getting here. And here we have a transfer function, and output is as usual C of S. Now C of S will be equal to what? So this is input, this is transfer function. Input multiplied by the transfer function, that is R of S plus minus X of S into G of S. And if we can elaborate this, C of S will be R of S, G of S plus minus G of S into X of S. So this is what we have circuitry. What is our aim? Our objective aim is shifting of a summing point. This is the summing point before from a position where from a before a block, because it's a before a block and we need to move it here. So that's what I'm going to draw. This is position A and we need to move it here to position B. So let me mark this by red. So from here position, we need to move this to position B. This position we need to move it. Okay. So let's see how we can do it. It's very clear. Two signals are coming. There's input signal, again input signal, and then RS. This is plus minus, plus minus. If it can be plus, it can be minus. We have written plus minus. Output from this summing point is RFS plus minus XFS, then transfer function. So output will be transfer function multiplied by input, and that we have written and we have elaborated it here. Next. So how we are going to do it? Let's see. Now here, okay, input is as usual. Sorry. Okay, input is as usual. Now what we are going to do, from position A, will be moving the summing point. Just a second. Yeah, sorry. What's that rule? Moving a summing point. Yeah. Just a second. Okay, fine. This is fine. Now from this position A, we are going to move this summing point. So summing point will not be there now. It's very clear. Now what will be here? Transfer function. So RFS directly will go to the input will go to the transfer function, because this another signal input is with summing point, so that will go along with the summing point. Now let me draw it. Now here it will be from input, just a second. Okay, fine. So this is I am drawing transfer function because summing point we have to shift. That's the objective. So this here will be R of S, and this will be a transfer function G of S. And now this signal, because we have to move it here, will go to the summing point now. Now the scenario of the signal here will change. What is input is given, transfer function is given, output is what? In output by input is transfer function. So output is transfer function multiplied by the input. So input multiply, we will write here. This is currently it will become now RS into GS because this point has to be shifted. Now we have to move it here. Now this input signal will go to what? This input signal will go to the summing point now. This input signal will go to the summing point now. Okay, it will go to the summing point now. Now what will be summing point scenario now? Sorry. Summing point level will be this. So this is a plus sign. As usual, it was in the, and this was plus minus. Okay, fine. Output to the summing point, you can see here, we have shifted it here, but this output is not going to change. This output is going to remain the same. So this output is going to remain the same from here. Sorry. Okay. This output is not going to change. This output is going to remain C of S. And that value of C of S we already know is R of S, G of S plus G of S into X of S. That we know. But how we are going to get this signal? This is very important. How we are going to get it? Because now R of S, G of S is input. What should be another signal? That we have to see how we can get it. G of S, X of S should be, we should get here G of S, X of X. So that means for sure it is clear that this signal, just a second, this is plus here. Sorry. This is plus and minus. Okay. Okay, for sure, this signal, see, input is R of S, G of S. This output, that means this value, total value is equal to what? R of S plus. So this means here it should be G of S, X of S, this signal. So that some of these signals will become, so it is very clear that here it is X of S, G of S. Sorry. X of S, this is very clear for us that this signal going to here will be X of S, G of S, so that output will become this plus this, so that we are getting. But what is the manipulation we have to do? Manipulation is that some block has to be here because transfer function is involved. You can see transfer function is involved and some block value is there and input signal to this summing point earlier we know that was X of S. So that is again we are going to do it X of S here. So input signal we definitely know is X of S. So output we know X of S by G of S. So output by input will be G of S. So this, if we will use the value of G of S here, then you can clearly see output by input is G of S. This together two signals will become out of S. So this is the manipulation. So that means what? That means in conclusion that if we have to shift a summing point from a position before a block to a position after the block, then what we have to do, we have to add a transfer function whose value is G of S. We have to add a transfer function in that case whose value is exactly the same as the previous transfer function. So that's the proof of this one. So next is rule number 6. Is it clear to everyone? Oh,
Yes,
Tanzib.
sir. Clear, yes, sir, clear.
Anybody has a query can raise this query. Integrity of the circuit will not change at any point of time. You have to keep the integrity as usual. What are the values we previously have? So next we have rule number 6. Rule number 6 is a bit converse of this same. Rule says moving a summing point ahead of block. Moving a summing point ahead of block. Okay. So how we can do this? Let's see how we can do this. So what is the scenario here? Same scenario we have taken above. We can take it for our reference. For our reference, we can take the same scenario. Okay. Now what we have here, again. Now here we have a block here. Okay. After a block, we have again a signal going to summing point. Then we have a summer. Okay. We have a summer. Then we have again output from here. Okay. So this as usual is R of S. This is your G of S. This output and transfer function means you have to multiply, sorry, input and transfer function multiply, you will get the output that we know now. This is plus sign and this is plus minus sign here. Okay, and this as usual is output C of S, and that value is, we have one more signal here, X of S. So input this signal plus this signal is R of S G of S plus X of S. So this is the output value we have. Now what is our aim? Our aim is to move a summing point, shifting of a summing point from a position after a block to a position before a block. Okay, we'll write it. What we have, what's our objective here? Sorry. Shifting of a summing point from a position after a block to a position before the block. So this is our objective. We have to move it like this as usual, as shown in figure. Okay. Now circuitry is in front of you in the block diagram. What is our objective here? I will draw it with the red. Objective here is from this position, this is B position, let's say. From this B position, we need to move this summing point ahead of the block or before the block. So how we will be doing it? Let's see. Now what will change here? First of all, we will have an input signal as usual. But that input signal will now go to what? That will go to the summing point very clearly. So we'll draw a summer here. That input point is going to summing point now. Okay, that's a summing point. Now, summing point, from the summing point, we need to see what is the result that we do not know now, because of what? Because some signal has to come. We don't know this. Let me draw this first and write for you. This is an input that is not going to change. Now this input is going to plus minus plus minus. Okay, here we don't know what's the signal coming. Okay, but here definitely no. Summing point has came here. After that summing point, there is a transfer function. There is a transfer that we know. That's not going to change. There is a transfer function. Fine. So here we know this is fine for us. This is a transfer function. And also what we know, the output, which is output of the circuit, is C of S, and that value of C of S is, we'll write it here, that we should get, we know this already, that should be R of S, G of S, plus minus X of S. That's above only. Output will not change by any means. Okay, so this we know. Now coming from here, we have to see, we have to make a situations like that. So we have to see what is given to us. We have to come from those areas. We have to look into inputs and outputs, and we have to find the other value. Output is given to us, that we know. Input is this. So output by input is transfer function. So here what we can do, output by, here I will write, output by input is transfer function. Transfer function we know, output we know, so we can write what? We can write input. We can write input here. How we can write input? Input we can write output divided by transfer function. That will be, this is output divided by transfer function G of S. So if we divide this by, I will here write for you. Sorry, here input will be here output divided by transfer function. So that is output by input is transfer function. Input is output divided by transfer function in this case. So output is R of S, G of S plus minus X of S divided by G of S. That will be R of S plus minus X of S, G of S. So that point we have got here. What the signal should be here? Here the signal should be R of S plus minus R of S plus minus X of S divided by G of S. So that signal we know. What is input coming to this block? That we have known, because we know output, we know transfer function, we can get this input. So what should be coming here? Now we can easily decide. This signal R of S is coming from here, okay, plus minus plus minus. This signal has to be X of S, G of S. Sorry. This signal has to be, very clearly, this signal has to be X of S, G of S. Okay. Now, how that we can get, because we know that from the summer previously, X of S signal was coming. So some block has to be adjusted here. Okay. And sorry, I'll draw it a bigger. Some block has to be adjusted here. And input going to that block, we already know. Input going to that block is X of S. That already we know. See, summer, from the summer it was coming. But now the signal is manipulated. Now output by input again is what? Transfer function. So if I do it like this, 1 by G of S, you will get output divided by input will be transfer function, or input multiplied by transfer function will be output. It is one and the same thing. So in nutshell, what we have to do, if we have to shift a summing point from a position before a block, before a block to a position, sorry, from a position after the block to a position before the block, then we have to multiply the transfer function by, yeah, not multiply, we have to take the reciprocal of the transfer function. Here we are taking the reciprocal of the, and it is converse to what we have done previously. It was g of s here, see here, now it should be 1 by g of s. So I think this is not so difficult, very simple rules, but integrity of the circuit has to be kept as it is, and other signals need to be manipulated accordingly. What are the given signals are to you, which are known signals to you? From those signals, you need to find the other parameters. Okay, let's move to the rule number 7 now. Rule number, what this rule says? This rule says this rule says that moving a takeoff point beyond a summing point. Sorry, moving a takeoff point beyond a summing point. So this is the what rule says. Let's see how we can do this. Now, what's the explanation of this rule? Shifting a takeoff point shifting a takeoff point from a position before a summing point to a position after the summing point as shown. Okay, let's draw this circuit. This is a very simple circuit. So input going, let's say the scenario is like this. Input going to the summing point is like this. Okay, this is the summing point. Then from that signal going from the summing point is the output. Okay, and then what we have again the output, sorry, this is input. So you can see here, this is your RFS. The same RFSs will be here. This is a summing point, plus minus. Okay, and signal to the summing point is X of S again. Oh, sorry. This is X of S. Okay, now this is R of S coming to here, and this is X of S coming from here. So output is C of RFS plus minus X of S. This is what output you are getting here. Okay, what is our aim? Our aim is to shift a takeoff point, this takeoff point, from a position before a summing point. This is a position before a summing point here. Here, let's say this position is A. From a position before a summing point to a position after that, means after the summing point we have to take it. So we have to take it like this here. So we have to take it here. This is our objective. This is our aim. Let's see how we can do this. Okay. Okay, again, Now summing point will come here. Input signal is not going to change. So input signal, sorry, input signal is as usual, RFS, that's not going to change. Now summing point will come here. So summing point will be shifted here to position A. Okay. So summing point has been shifted and the signal is this one, plus or plus minus. So one more signal is coming. Summing point has got a signal of X of S. Okay. Now from that, you can see summing point has been shifted where we have to shift a take-up point, sorry. Take-up point has to be shifted. Now summing direct signal will go to the summing point and this has the signal. That's fine. Now this will be moved here. So as usual, the output integrity is not going to change. Output is going to remain same because we are only moving takeoff point. R of S plus minus X of S. Now this output, now this point is moved here. This point is moved here. What we know, input to this point will be manipulated now. We can write here. Input here is R of S. Okay, this is X of S. This is your point A. Now we have reached to the point B. Somewhere we can say point B. This was point B. Okay. Now here, this is R of S plus minus X of S. That same signal is going to as an output. But then R of S is here. So how that signal is take-up point is going to be manipulated, you can see. So this is a, sorry, this is a takeoff point here. Okay. So this is going to something, we'll see that. But for sure, we know that output again here is, just a second. For sure, we know that output here is again R of S. Here output, you see this output is R of S. So that we know. So what is coming from here? So coming from here is, so if we see what should be here, so one of the signal going to is R of S. Then if one of the signal going is R of S, then we should have a reverse signal as minus plus X of S, because that will nullify the plus minus X of S. I'm going to repeat again. So we should have a signal here that is minus plus X of S. For that, we require what? We require a summing point. You can see here. So we require here a summing point. So we require here a summing point. Here the signal will be plus. That's not a problem. Here, because we need a signal output. If this is the scenario coming here, RF, this is same here coming. RFS plus XFS is here. There is no block, nothing. So it's coming, signal is coming here. So input is known, output is known. So this value of signal here has to be, this value of signal has to be minus plus X of S, so that, sorry, minus plus X of S. So this value has to be X of S. So if you add here a signal coming up to the here, so I can write it for you for those who have a confusion. Now up to here is coming what? R of S plus minus X of S. This is an input. That means this plus signal to what? To summer. Now this signal we know and this output we know. So we have to manipulate this here signal. How it can be manipulated? We have to nullify this signal. How to nullify this? Instead of plus minus, we'll be writing minus plus, and this will get cancelled off. So this signal gets cancelled off. We are getting output. So integrity of the circuit remains. So in the nutshell, we have done what? If we have to move a takeoff point from a position from a position before a summing point, that is before a summing point to after a summing point, then what we have to do? Then we have to add a summer. Sorry. Then we have to add a summer whose signal will be just opposite to that of signal what we have got. That signs of the signal. That if it's a plus minus, it will be minus plus. It's a minus plus, it will be plus minus. That's all. That's all we have to do when we are doing such type of manipulations, or well, we have to do such type of modification in reducing the block diagram. Okay. Next is moving a takeoff point. That's the rule number 8. That's moving a takeoff point ahead of a summing point. Ahead of summing point. What's the explanation of this? Explanation is shifting of a takeoff point takeoff point from a position after a summing point to a position before the summing point. As shown in let's see. So next is underline this point. Now, what is the scenario here? We have to move a takeoff point ahead of the summing point. That means takeoff point from a position after a summing point to before. So let me draw the circuit. This is an input signal. Then we have a summer. Okay. Then after the summer, we have as usual out. Sorry. We have as usual output. Okay. As usual we have, and here we have a summer. Okay, so we can see here what's happening. This is input as usual, RFS, and this is plus and plus minus, another signal coming from here, X of S. So output as usual is going, in both cases the output is same, that is R of S plus minus X of S, and this output is also same. C of S is R of S plus minus X of S, because it's the same place. Okay, so in both cases output is same, so value has to be same. So this is the value. Okay, this is the actual. What we have to do, pick a point. Second. Assalamualaikum. Sir, class ki bukaro to iskar. Not what we are doing. Sorry. So we have to move a takeoff point ahead of the block. So we have to move this takeoff point. Let's see. Takeoff point here. So let's see. This is a position B and this is a position A. That's what is our objective. Sorry. So how we can do it? Input is not going to change. Now the takeoff point will come here. We'll see that. Sorry. Okay. So what we have here, the takeoff point will come here, but the input signal is not going to change. Okay. So we will have a summing point as usual here. Here we have a summing point as usual, because summing point will remain there. Only the takeoff point is going to come here, and output is going to remain the same. See here, the output is going to remain the same. That output. Have a look. Plus minus. This is your input R of S, and this signal is again not going to change. This is X of S as usual. This is your X of S signal. Okay. Now we need to move this to the position, this here position. So we'll move now takeoff point. So this is the takeoff point we are moving. Okay. Now in moving so, we have to see how we can move this. Now this again, sorry, this is same. You can clearly see this output is not going to, this output from takeoff point, the output is same. So I'm going to write that. So here we have what? Here we directly have this R of S, C of S. Here on the top, it is not going to change at all. R of S plus minus X of S. That's not going to change at all. But in this case, now we know this output is same. Again, the same type of manipulation that to be done. What are known quantities? What are the known values? From the known values, we have to get the unknown values. Output here is known. Input coming to this is also known. You can very clearly see input is also known. But then what should be the signal here? So that we will get this R of S plus X of S. So definitely we should have a summing point. Definitely we should have a summing point again. Okay. Okay, we should have some point. this signal has to be plus, and this signal has to be plus minus. So clearly, it has to be plus minus what? Simply x of s, nothing else. RFS, we are getting up to here. So this is here up to here. This all is RFS as usual. Output is XFS. We need to simply give a use a signal of X of S. So while we are moving a takeoff point from a position after after a summing point to a position before a summing point, then what we need to do, we have to add a summer whose value of the signal is exactly same, not as the previously we here. The value is x of s here, and the value here is here x of s. So that means we have to move this summing point plus minus, and that will be here it will be plus minus. But in the previous we had minus plus. So signals, only the difference of signal is there, that instead of plus minus plus we will have again the same signal, that is plus minus. So that's all for today. I hope can stop.